All right, our final presenter is from Ecolab Life Sciences. She is Johanna Housen, lead application scientist. Her presentation will explore the market growth of complex molecules driven by advances in personalized medicine and biotechnology. Great topics. We will identify key drivers and discuss the primary challenges in purification, including purity levels and process efficiency. Welcome, Johanna.
Hey, thank you very much for the introduction, Perry, and thank you everyone who's joined this Bio Expo live event. I'm really pleased to be here. Just to cover, we will cover the purification of complex molecules, the market growth challenges, and solutions. So just before, I've accidentally left the pointer on there. Just before we jump in, to give a brief introduction to myself, I'm Johanna Housen, as Perry said. I'm the lead application scientist for Ecolab Life Sciences. I'm on the Purelight Resins department. I'm based in the UK. The agenda for today, I'll give you a brief introduction to Ecolab Life Sciences and then talk through some of the trends we're seeing in the growth of complex molecules, and then give a case study on how some of our Purelight resin innovations are supporting our customers with challenges when producing these complex molecules. So to give you a brief introduction to Ecolab Life Sciences, for 100 years, the company has worked to improve the health of people, planet, and businesses around the world. We aim to lead with science-based solutions in many different industries, and this includes helping to maintain clean and safe environments, helping to optimize water and energy usages. And today, of course, I'll be talking about how we support the pharmaceutical industry. So Ecolab Life Sciences are committed to investing in the pharmaceutical industry through continued innovations. So today I'll be talking about some of the innovations coming from our bioprocessing team, and this is in the drug development process and using Ecolab's Purelight toolbox resins. So this is a bit of intro slide that's quite similar to Paul's. So we're seeing this continuous trend here with diversification of molecules, including the diversification of mAb-based molecules. So there's been this really huge innovation in the past 20 years. If you look at this graph for 2003, there are around 400 antibody-based molecules. This is from preclinical stage to like full manufacturing stage. And of those, about 90% were monoclonal antibodies. However, jump forward to 2023, and there are over 3,200 of these molecules going through the pipeline. And the monoclonal antibody component of that group has gone from about 90% down to 59%. So we're seeing this kind of increased growth in bispecifics, multispecifics, other complex molecules such as the antibody drug conjugates. And this is really exciting because it's opening doors for treatments of diseases that were previously very difficult to treat and improving patient care. However, they come with some challenges, and as vendors, we're required to continuously innovate to keep up with these new challenges brought by complex molecules. So I want to just pick out two of our Purelight resins, and these are both affinity resins that kind of help towards the challenges that we see in this moving industry. So some of the common challenges we see with these complex molecules are the kind of increased complexity often reduces the molecule stability and decreases the yield that we can get compared to a typical monoclonal antibody. As well as that, they come with quite a unique landscape of impurities, both process and product related impurities that can be quite challenging to clear in your downstream processing. As well as that, of course, the viral clearance is a really important step in your downstream bioprocessing, and this can be challenging in these complex molecules. As well as this, the features of your processes that enable your product quality need to be scalable, and that's another really important thing that we need to think about as a vendor when helping these complex molecules go through the scales. So firstly, I want to point out one of our resins. This is the Presto 70 CH1 resin. So this is a 70 micron aggro speed with a ligand that binds very specifically to the CH1 region. So this is very good if your molecule doesn't have an FC binding region, an FC region. So say a fab fragment. It also can be used for biospecifics if you're trying to remove some closely related impurities from your process. So that's one of the options we have in our affinity toolbox. And then I want to draw your attention next to, I missed a slide. One of our protein A resins. So this is Presto Jetted A50 high pH, and this is based off of our flagship protein A resin, which is Jetted A50. However, the ligand for this protein A has been engineered to improve the elution profile of pH-sensitive antibody molecules. So typically in a protein A affinity step, you would need to elute your molecule between pH 3 and 3.7. Having a pH higher than that, you start to kind of have a considerable drop in yield of your molecule. So this can be an issue for these complex molecules that often have poor stability in that low pH hold. So I've got a case study and some data to show you kind of the benefits of this high pH resin. So firstly, we're starting with this work from Biogen. So I think a lot of our customers know better than us that when you're doing these downstream processing steps, you will often cycle, and you'll need to pull the eluate from your cycle 1 of your affinity step into the pool of cycle 2, cycle 3 onwards. So often there are times where you're having to hold your product in the elution buffer from that cycle for extended periods of time. For these complex molecules that have reduced stability at that low pH, it can be a problem. So Biogen published this work in the Journal of Chromatography in 2023. They generated a number of Fc fusion molecules, and this one I've picked out here was known for having poor stability at those lower pH holds. So they tested the Jetted A50 high pH resin, our other protein A Jetted A50, and a competitor. And you can see with typical protein A processes, the longer the product, this Fc fusion product, was held in that elution buffer, the more high molecular weight content. So this is indicative of the antibody aggregating due to poor stability. So your high molecular weight components go up, which means more impurities to clear downstream and also a lower yield of your good quality product. So you can see the line in blue is eluate from our high pH, and it remained stable throughout the whole 48 hours tested. So that is due to the pHs you can use with that resin. So using the high pH protein A resin results in high yield at those milder pHs. So if this is work done by IMCS, so they're a US-based company that make tips for high throughput purification. So you can do lots of high throughput analysis with different resins, which is quite cool. And the team of scientists led by Patrick Cates ran a few purification cycles with different molecules and different resins at different pHs to kind of test the ability of these resins to get a good yield. So on the left-hand side, this is a map that they used, and you can see that from pH 3.7, you get quite a decrease in yield if you're increasing the elution pH. But with high pH, it's a definitely more shallow decrease. So if you do have a molecule that requires those pHs at 4 and above, you can use high pH up to generally about pH 5. You do get a much increased yield compared to a typical protein A resin. And they saw the same thing for the bispecific antibody that they used, and this is the graph on the right. You see a general downwards trend, the higher the pH, but with our Presto Jetted A50 high pH resin, you get improved yields if you're needing to use those pHs. So as well as the improved stability and the yield that you can achieve with the Jetted A50 high pH, it also can improve impurity clearance. So we've got some data here that we tested a few different molecules in-house for impurity clearance with our high pH resin. So I'll start with the graph on the right. So here we've got an Fc fusion, a MAB, and a bispecific. We're testing the high pH resin comparing to Jetted A50, our other protein A, and 2 competitors. And you can see that in every case, the high molecular weight content is the lowest for the Jetted A50 high pH resin. So even in this bispecific that we knew was very challenging and we knew had high molecular weight content, you get much lower content when using the high pH resin due to that milder elution. And then if we move to the left, we can see that this is on the y-axis, the HCP log reduction. So this is the host cell protein removal from these 3 different feed streams. And again, we see the kind of best case scenario in all 3 molecules for the jetted A50 high pH resin. So it's got improved HCP log reduction compared to other protein A resins on the market. So this helps in both, it helps alleviate challenges in both upstream and downstream processing. So if your high molecular weight content's high, for example, you'll need to put more load material onto your protein A step in order to get the same amount of quality product at the end of your affinity step. So by having less high molecular weight content, we're alleviating some of the burden on upstream. And by improving the log reduction of host cell proteins in the step, we're also alleviating some of the downstream steps that are required for HCP removal further downstream. And also, it's not just the host cell proteins we needed to consider. Of course, it's very important that the affinity step for these molecule processing has good viral clearance. So we were able to do 2 studies to show the ability of our Just A50 high pH resin in viral clearance. So on the left, we've got a full viral clearance study. So this material has been spiked with typical models. So we've got the enveloped MLV virus and the non-enveloped MMV virus. We looked at Presta Just A50, our high pH resin, and a competitor. We picked at first just a kind of a standard pH that you would perform your protein A elution at. So that's pH 3.5. You can see that for both resins, it's about 2.5 to 3 log reduction, which is expected for a protein A step. When we ran the high pH with an elution buffer of pH 4.5, actually you see an improved log reduction, which is exciting to see. So on the right, we were able to do a second study, and this was with virus-like particles. So this is the MockV kit from Cygnus. We were able to expand the resins that we looked at and expand the pHs that we looked at. So as well as before, we've added in another competitor and looked at some other pHs, and we see a very similar trend. So these were 2 different molecules as well. It's an IgG4 and an IgG1. We see the same trend where you get about 2.5 log reduction at a typical elution step of pH 3.5. And there's a very clear trend that the higher the elution, the better the viral clearance. So yeah, we're excited to see that the impurity clearance is improved when using the high pH, as well as the product yield and quality at the end of the runs. And finally, I just want to talk about process scaling. So the features that the high pH resin has makes it primed and ready for large-scale commercial processing. And as well as those features, we offer a lot of support and guidance when using our resins and scaling them up. So we have 2 applications lab. We've got one based in Europe, so in Wales, UK, where I am. And then we've got a brand new state-of-the-art facility in Pennsylvania. So customers are able to actually attend that facility and work side by side with our bioprocessing experts to really make sure our solutions are tailored to your unique needs and your unique molecules, and help implement some of our new innovations like the Just A50 high pH. And I think I went through that a bit quickly. But please feel free to ask me any questions. I think we've got a bit of time left.
Thank you, Joanna. Yes, very good. Great presentation. So you talked a little bit about scaling to commercial levels. Is high pH available in large scale for commercial processes?
Yes, it's already available for those processes.
Okay, great. All right. So crystal ball time. Okay. We always have one of these questions as well in our event. It's always good to talk a little bit about trends. And for you, specifically related, what kind of trends do you see for biospecifics and other complex antibody molecules?
Yeah, I think they will continue to go in the way that we're seeing right now. So there has been this big boom in kind of the number of molecules and the diversification. And I think it will continue to go that way. So the market trend data that we have suggests kind of a further move towards those complex molecules. So it's something that we keep in mind when we're thinking about our own innovation pipeline. And we work very closely with customers to anticipate the challenges that will come from that direction the industry is going in. So yeah, certainly I think it will continue to go in that direction and move towards more complex molecules.
Yeah, it certainly feels that way. Yeah.
Mm.
So here's another question. This is kind of specific, and I'm trying. So we have a question about resins that are resistant to clogging. How many cycles can it operate without replacement? Does that make sense? That question?
Is I suppose that's perhaps more fouling and cleaning. So all our protein A resins are caustic resistant, so to varying levels. So say our Duracycle A50 resin, that is the most caustic stable. This high pH one is less so, but it is caustic to 0.1 molar cleaning. I might have to get this specific data, but I think it is around 100 cycles. And yeah, we don't suspect that you would need to repack or change the resin in that time.
Okay, awesome. So that came from an audience member, Al. So perhaps you can get with him offline and
we'll have data
more
we can
about
share.
that.
Yeah, definitely. Thank you for the question.
Yeah, all right. And one final question, going back to the previous one, do you have any other resins in development for complex molecule purification?
Yes, I probably can't say too much, but I will say that new resin development is a really key part of Ecolab's kind of innovation strategy. So it's something, there will definitely be more coming for the Purolite toolbox of resin, certainly. Yeah, wait and see, I suppose.
Okay, we'll sit on the edge of our seats waiting for that. Thank you. Johanna Housen from Ecolab Life Sciences. Thank you very much for being with us today.
Thank you, Perry, and thank you, everyone.